Hello everyone, I'm Neila Najai Labidi, a researcher from the Faculty of Sciences of Tunis, Tunisia, and an assistant professor in the Higher School of Food Industries, Tunisia. Today I'll be presenting a study entitled Material Heritage, Leading Technological Evolution, a Scientific Analysis. So let's begin by a small introduction. As we know, industrial progress is leading to more modern and comfortable human life, but it has also a bad impact on air and water, and it distances also man from his rituals and heritage. So every coin has two sides. As we know, science is contributing to the conservation of cultural heritage. But in the other sense, has heritage inspired the industrial and biotechnological process? That's what I'm wondering. In this context, I'm aiming to valorize heritage by a better understanding of ancestral lifestyles and ingenious methods to adapt them to present-day needs. We can summarize the main present-day needs in three vital sectors, which are energy sustainability, water preservation, and food security. And all the three are aiming to avoid waste and to secure a livable future for people and planet. So let's begin by the first part, which is water preservation. And I've chosen as example for material heritage measure, which I'll be explaining in the next slides. But before, let's take a look at the Tunisian hydraulic heritage. Tunisia is covered in long ruined cisterns dating back to Roman times. These are in the city of Zagouan, aqueduct systems carrying the water from this city to Carthage. Also in the amphitheater of El Jam, there were underground cisterns. And in the city of Kirwan, there is a sort of basins called Fiskeya. But what about Mejel? Mejel is an underground built for water cisterns, and it's collecting the water through pipes. And here is the scheme of Mejel. And here how water is collected in these cisterns. This traditional system was widespread for many centuries, especially in the 10th century, in the city of Sfax, where its water has a well-appreciated flavor, as it's mentioned in the book of Ibn al-Haqq. This method has largely been abandoned in Tunisia, but it still persists, especially in certain arid regions, as indicated in the article published in 2022. These are photos illustrating the top part of Mejel where water can be retrieved. With the water, I want to say that with the water shortage the world is facing, reviving Mejel can be one of the solutions in association with modern technologies. Nowadays, there is a return to rainwater harvesting, RWH, in a modern way by filtrating the collected rainwater using automated pumps and sensors for monitoring water level and quality. For example, in some regions in European countries, as in Barcelona, they are promoting the use of RWH. And in France, since the 1990s, where this practice is legislated. Now, let's move to the second part, which is energy sustainability. And I've chosen as an example, Botijo. As it said, necessity is the mother of invention. As far as the Neolithic period, man was creating vessels to firing clay to use it for keeping foods. Then he has discovered that these utensils can also cool their contents. And here are some photos of Tunisian potteries with different use, and they are conserved in the museums. Regarding botijo, which has a very special shape, botijo is defined as a porous clay pot used to cool water. And as it mentioned in an article, in a recent article, this jar was the most used portable water cooler in the homes of half Spain 80 years ago. The concept that makes botijo cool water is the evaporative cooling. Botijo is made of pottery that has not been fired to the point of vitrification, so it has some pores. And the liquid water will exude through these pores to be transformed in a gas phase by evaporation. And the energy sustaining the evaporation comes from the internal energy of the liquid and induces to its temperature reduction. It is almost like the body transpiration that makes its temperature lower. Here is a very interesting study led by two Spanish chemists, allowed to determine the factors that are controlling the efficiency of evaporative cooling. They have simulated a summer day by putting the botijo in an oven, and they've discovered that the temperature fell from 39 degrees to 24 degrees in 7 hours. And according to the equations that furnished by these scientists, water temperature variation with time involves many parameters. Among them, the shape of botijo, the outside temperature, the shape and the amount of water within it, and humidity. A study of the optimization of the shape of botijo was carried out in 2021, and here they have revealed which shape can permit the quick cooling and which shape can get the coolest water temperature. Concerning humidity, another work where the world was mapped according to very dry regions and where evaporative cooling is efficient, and other regions where it is not. For example, on the map of Spain, we can distinguish differences in humidity between Madrid, which is the lowest, then Valencia, then Gijón. And on the right, there's diagrams, and these diagrams allow us to predict which is the humidity temperature according to the relative humidity. When the relative humidity is low, the humidity temperature is also low. And the information that is bringing the humidity temperature is the theoretical minimum temperature that the water contained in a botija can reach. So for example, here from 25 degrees for 30% of humidity, we can get a temperature around 15 degrees. This inventive concept has prompted modern application in refrigeration and also in architecture. A study of the effectiveness of evaporative cooling in porous ceramic pieces was realized to identify the most suitable areas in Spain for this system. And this is a prototype design for the application of the evaporative cooling in ceramics. This thermodynamic process also was exploited to invent a clay refrigerator, as you see here, that operates without electricity. So all these examples are permitting an economy of energy. Now let's move to the last part, which is food security. As an example, I've chosen Shakwa. I will say again that necessity is the mother of invention. You know very well that milk is a rapidly perishable product, and farmers used specific tools to their regions to transform it into other easier to store products. Here, by using Shakwa, an oscillating movement of this primitive churn called Shakwa, and which is suspended by a tripod, causes the coagulation of water. Shakwa is obtained from a goat or lamb skin. Here are some examples of dairy products in Maghreb countries, in Tunisia, Algeria, and Morocco, that can be obtained by using Shakwa. For example, the fermented milk called البن, the batter, the rancid batter called smen, and an extra hard cheese called klila. The technology transfer to industrial scale for the production of milk, cheese, and butter began in Tunisia around the 1940s. 1/10 of the milk collected was processed into butter, as it is mentioned here in an old document. The production of butter in both small and large scale implies churning in their process, so like the traditional one by using Shakwa. And here are different types of machines used to produce butter. By focusing on the artisanal process of using Shakwa in its finest detail, a form of genius is revealed. The various steps were later explained through scientific principles, and the main principle is the phase inversion. And the phase inversion happens when the fat droplets in the cream gather faster by churning and become oil. And that's how butter is produced. The industrial production of the fermented beverage called البن has begun in Tunisia later in the 1990s, and a comparative study dealt with the traditional and the industrial production of البن has revealed that the traditional one is more aromatic and better appreciated by consumers. So significant progress have to be made in order to match this traditional process. As a conclusion, I will say that bringing material heritage to light raises the awareness of the ingenuity and significance of our ancestors' contributions and inspires further adaptation and modernization of these timeless methods. At the end, I will say Thus, this work has not only involved chemistry, physics, food technology, but also history and ethnology. And I won't be able to achieve it without the help of Institut des Belles-Lettres Arabes Tunisia, which has furnished me the documentation, Institut National du Patrimoine for the discussion with some members. And I also want to thank la Asociación de Arqueología Industrial España for this opportunity and also for their continuous encouragement. And I thank you all, and I hope that the next year I will be able to attend in person. Thank you again.